Hello everyone, welcome back to my channel. In today's video, we are diving into super important topics in computer networks, error control. Ever wonder how your data stays accurate while traveling across noisy networks? Let's get started. Introductions to error control. In digital communication systems, data is transmitted over various channels that are often prone to noise, interference, and other impairments. These factors can cause errors in the received data. Bits may get flipped from 0 to 1 or vice versa. The techniques to detect and correct errors in communications, ensure reliable data transmissions over noisy channels, implement a data link layer and transparent layer. There are two main types of this error control: error detection, error correction. Mm. Causes of these errors: electrical noise. Electrical noise, random electrical signals that interferes with the data signal source, including lightning, motors, or other electronic devices, can flip bits during the transmissions. And attenuation, loss of a signal strength at a as it travels over a long distance. Weak signals are harder to detect, leading to incorrect data interpretations, especially common in wired networks and optical fibers. Crosstalks means occurs when a signals from a one channels or a wire leaks into another. Common in a bundle cables where the wires are placed close together. Causes distortion in a original signals. Interference. External signals like a radio waves or electromagnetic fields distribute data signals common in a wireless networks due to overlapping frequencies can result in a temporary loss or a corruption of data. Hardware faults means faults networks devices like routers, switches, or cables can causes intermittent or consistent errors in the data transmissions, may lead to repeat transmissions or complete communications failure. Types of this error. There are two types of this error: single bit errors, burst error. Single bits errors, only one bit is changed. Only one bit in the data units like a bit or a frame is a change from 0 to 1 or 1 to 0. Um, and Causes of the single bits error typically caused by the random noise or a signal disturbance, and the detection easy to detect and correct with the basic error detection codes like a parity bits. Burst error, two or more bits are changed. Two or more bits in the data unit are changed. The errors can occur in a sequence or scattered across a small block. Causes of this burst error often are caused by the crosstalk, interference, or hardware faults. Detection more complex and requires advanced error detection techniques like CRC. Error detection vs error correction. Now see, error detection. Error detection detects presence of errors. It identifies if any errors has occurred during the transmissions to detect errors in this received data. And the error correction detects and corrects the errors, identify and corrects the errors without needing transmissions to fix these errors and recover original data. Detection is a simpler, correction is a more complex. Uh, and the error detection alerts the receiver transmissions is request. Ac- and the error correction corrects the errors using a redundant data. Techniques used in error detection: parity bits, checksum, CRC. Error correction: in the techniques used in error correction, Hamming code, Reed-Solomon code. Retransmissions in the error detections, yes, usually requires transmissions, and in the error detection, error and in correction, no retransmissions needed. And the error detections are suitable for reliable networks with the low rates, and the error correction suitable for the noisy or one-way communication. Error detection techniques: parity bits, even odd parity bits. The concept of this parity bits adds a one extra bits parity bits to the data to make the total number of 1s, even parity bits or odd parity bits. Um, for example, data is 101,001, parity bits even 1, sends 101,001,1. Its limit is its limitations detects only single bits errors, not multiple bits. It detects only one bits, not multiple bits. Checksums. The concept of the checksums: the data is divided into the blocks and sum of this block is calculated. The checksums inverted sums is sent with the data. At the receiver also calculates the checksums. If it does not match the received one, an error is detected. Checksum sum of the segments. Cyclic redundancy checks. Polynomial based checking means treats the data as a larger binary numbers and divided by the fixed binary divisors called a generated polynomials. The remainder in the CRC at the receiver data plus CRC is divided again if the remainder is not equals to 0. An error is detected. Very powerful, detects burst error and widely used in a networking like Ethernet, DSL, USB, etc. Error correction techniques. Error correction techniques not only detects the errors in transmit data but also reconstruct the original data without needing a retransition. These techniques add redundant bits to the data which helps the receiver identify and correct errors. Uh, Types of the error correction techniques. Forward error correction. Here are the types of this error correction techniques, which is a first a forward error correction, automatic repeat requests. Forward error corrections means adds a redundant bits, no transmitted needed. Redundant bits are added to this data before a transmission. The receiver uses these extra bits to detect and correct the errors automatically. Note retransmission is needed means ideal for the real time or a one-way communication. For example, video streaming, state light links. Automatic automatic repeat request means retransmits on a error detections concept. If an error is detects the receiver request the sender to retransmits the data used in the systems where the feedback is possible, like a reliable TCP communications. And the types of this automatic repeat request are stop and wait, automatic repeat request, go back, and automatic repeat request, select repeat, automatic repeat request, select two. Hamming code. Hamming code detects and corrects a single bits error. Uses a multiple parity bits. Means Hamming code is an error detection and correction method invented by the Richard Hamming. It can detect and correct a single bits error in a transmitted data by adding redundant bits, parity bits at a specific position. Determining the number of the parity bits. For example, the data is 1011. Um, if the total bits is a 7 and the four data, wait a minute, the total bits is a 7 and the 4 is the data bits, which is this, plus the 3 parity bits positions, 3 parity bits positions, 1, 2 and 4 are parity bits. Means P1, P2, D3, P4, D5, D6, D7. Set the parity bits. P1 checks the beat. Wait a minute. P1, P2. Yeah, ये तो हो रहा है. Means the data bits are the 4 and this and the 3 plus 3 parity bits positions 1, 2, 4 are the parity bits. P1, P2, D3, P4, D5, D6, D7. P1 checks the bits 1357 and P2 checks the bits 2367 and P4 checks the bits 4567. Set each parity bits to make the total number of 1 as even in its group. Then P1 bits, P1 is 0, P2 is 1 and P4 is 0. Then the final encoded data is 0, 1, 1, 0, 0, 1, 1. Importance of this error control. Uh, ensures the data integrity and reliability communication. Ensures data integrity, detects and corrects errors so the data received is exactly what's sent, and improves reliability, makes communication reliable even on over noisy or faulty channels, reduces retransmissions, supports critical applications, enhance network performance, means minimizing the delays and improves the overall efficiency by handling the errors effectively. Criticals for file transmission, media streaming, online communication. Uh, at the end, conclusions. Error control techniques improves communication reliability. Choice depends on the application and transmission environment. Error control is a fundamental part of a computer network that ensures the data is transmitted accurately and reliably. Deposit noise interference and hardware faults. By using techniques like error detection, error correction, networks can maintain data integrity, improve performance, and supports critical applications. Understanding these concepts helps building strong foundations for deeper learning in networks and communication systems. If you are any questions, you can comment. You can send the question in comments. Thank you for your attention. Um, I hope this helps you understand the difference between error detection and correction and how techniques like parity beats, CRC, and Hamming codes works. If you uh, don't forget to like, share, and subscribe for my computer network topics. Thank you for watching, and I will see you in the next video. Bye.